Welcome to this investigation briefing. I've gathered here you all today to help crack a serious case. Here's what we know. At exactly 7:12 yesterday, we reported major slowdowns across our entire front end. Dashboards were showing red and load times increased to tens of seconds. Tens! That's enough time to go to Ynet, then go to Instagram, then check WhatsApp, and then go to Ynet back again. And half an hour later, users started complaining about the app not responding. And you know it's bad when users start complaining. One thing we know for certain, our app's performance is dead. We sent 2 junior front-end investigators check, but we haven't heard back from them since. As of now, we have no suspects, no leads, and absolutely no patients left. We're here to solve this crime together. But before we dive into that, let me introduce myself. My name is Opher. I'm a developer, a designer, a musician, and sometimes I'm a fake police commissioner. I work at HUD, where we build a platform that shows you why production is breaking down or slowing down without having to reverse engineer everything by sifting through logs. Now, for this briefing agenda, we're going to talk about common performance pitfalls. And performance is kind of tricky in React. You usually don't notice that something is wrong. Performance issues tend to tack up until it's too late. So I'm going to show you how to solve them yourself using some tools and methodologies. And then I'm going to show you how to have someone else solve them for you. Now, to help figure out why our performance is dead, we have several detectives joining us remotely. And let me tell you, that's quite a lineup. Now, we have to start by asking ourselves, when does stuff get re-rendered? And let me be more specific. What do I mean by rendered? Where did that come from? In the context of this talk, rendered means calling the, what the? I think someone is calling us. In the context of this talk, rendering means invoking the function in the functional component. So rendering could mean pushing pixels to screens or pushing textures to the GPU, but in this talk, it means just calling this the function. Now, what causes a component to re-render? So first, a component re-renders when one of its parents re-renders. There's an asterisk there. We'll come back to that later. When its props change, when its state changes, or when its context changes. Wait. And this is by no means an exhaustive list, but things aren't so simple in the React world. And now we do have actually a Zoom call. Hey, it's Batman.
I'm Batman.
I know, it's kind of easy to see with the pointy ears at all. I didn't think we need Batman to solve a performance issue, but I guess here you are.
I'm Batman.
Yes, we've established that. That's why you're here. So what did you find?
2 problems. First, the app had used context, which kept updating all over the place. The more it changed, the more chaos it created.
Interesting.
Second, it was creating new objects, arrays, functions, in props on every render. That constant churn adds up, Commissioner. It's unnecessary work. And in a case like this, unnecessary means slow.
Okay, those are solid leads. Let's break it down. Use context. A really quick recap. So in the React world, we have a pattern called prop drilling, which basically means this. Sometimes you want to pass information from a component up in the rendering tree to a component down in the rendering tree. So in this example, we have this parent component, which sends a message, hello from app, passes it through a child component, then a grandchild component, then to the child component, then to the grandchild component. And to solve this prop drilling, because the rendering tree could be quite deep, we have something called context, which works like this. You have a context provider. You define it in the top section, like in the topmost part of your app. And then you have a consumer that uses the use context hook. In this case, this is where we define our context. And then there's the parent and the child that don't care about the context. And then the grandchild uses the use context to show the message. Here's the thing. Use context is a hidden foot gun. And if you've never heard the term foot gun, it basically means something that makes it very easy for you to shoot yourself in the foot with. And in use context, it comes in several common practices. So first, let's take a look at this example, this authorization provider. You have your app, and sometimes you need to pass along the username or the user email to multiple components. So this is the authorization context provider, which has the username and the user email, and assume like this comes from some sort of payload somewhere. Now here's the thing. You see the value where we instantiate the username as the password. That's a new object that it is being created on every render of this authorization provider. Regardless if these changes, if the username or user email changes, this is because this is a new object. And I see this pattern all the time. The same happens when you have functions, for example. So here you have this authorize function that is defined in the context provider and is passed along as the value of the context provider. But again, function is being recreated by reference. It has a new reference every time, and that makes the value of the provider unstable because it changes every time it gets rendered. Okay, so what is the solution for this? To memorize the values that are being passed along to the context provider. How does this look like? You have your value this time in use memo. And we have the payload in the dependency so that the context value only changes if the things you care about change. And that means that the consumers of the context will get re-rendered only when the value changes, which originally changes only when the things you care about changes, and not like we saw before, where any consumer will change regardless if the value changed or not. Okay. Same goes for function references. For those, use callback, and again, that makes the reference to the function stable. Anything else, Batman?
Optimize your renders, Commissioner. Gotham may be a mess, but your component tree doesn't have to be.
Thank you, though I've got to ask, aren't you more about fighting crime than solving JavaScript things?
Crime takes many forms. In JavaScript, that's the worst kind of crime.
You're not really a detective, are you? You just go around dressed like a bat, beating people up?
You're not really a police commissioner either, are you? You're just a nerd, standing in a room full of other nerds.
Fair enough. Thanks, Batman. Let's see. Next up is, oh no.
Go, Gadget Desperate Cam. Hang on. Let me just... Go, Gadget Bluetooth headset.
The Bluetooth device is connected successfully.
Gadget, are you driving on this call?
Of course, Commissioner. Multitasking is the future of crime solving. Besides, Penny upgraded the Gadget Mobile. Fully autonomous. Completely safe. Anyhow, go, Gadget Performance Insights.
Okay, so what do you have for us today?
Do you know what happens when you pile too many use effects on top of each other, Commissioner? You get a mess. A big, tangled, buggy mess. I tried to debug it myself, but even my Go Gadget debugger crashed halfway through.
That does sound inefficient.
Inefficient? Commissioner, it's a disaster. Instead of solving problems, it's creating extra renders, unnecessary dependency checks. It's an absolute chaos. Whoever wrote this was just tossing in use effects like sprinkles on a cupcake, without even checking if it was needed.
I see. Anything else?
Oh yes, use memo and use callback. These are precision instruments, but they're being used everywhere. It's like the developer thought, why not memoize everything? So now, the app is spending more time memoizing than actually doing anything. It's ridiculous.
So you're saying they turned hooks into liabilities instead of tools?
Exactly. Too much of a good thing, Commissioner. If they just stopped to think before deploying every hook they could grab, we wouldn't even be having this conversation.
Okay, thanks, Gadget.
All right, Commissioner. That's all the intel I've got. Time to head to my next mission. Someone reported a toaster that is throwing errors in production. Go, go, Gadget. Seatbelt. Yeah!
Okay, use effect. Let's do a quick recap. I'm not going to go through all of use effect because that will take a few hours. Let's do the basic minimum. So, use effect is used for... Someone said effect, that's wrong. It's used for data synchronization. And sometimes it can be used for side effects, but only as a last resort. And you don't have to trust me, just trust the React documentation, which says if you've exhausted all options and only as last resort, you can also handle side effects using use effect. Okay, so if you want to know more about this, there's an excellent talk called Goodbye Use Effect by David Korshid, highly recommended. Here's the thing with use effect, that's also a foot gun. The first flavor of foot gun is the right values, and let me give you an example. This is a component called name component, which has takes full name, takes first name, last name, and then with an effect, it outputs full name. Here's the thing though, every time one of the dependencies changes, first name or last name, that changes the state, which again, like we learned earlier, changes the component. So you have an extra render every time the input changes, like first name or last name. And you don't really need that because you can kind of figure out what the full name is from the first name and the last name without the effect at all. And I know this is a simplistic example, but I see all the time where components receive arrays or data structures and then do filtering or extra data manipulation. And you don't have to do that with effects because, again, the data is derived. So let go of those extra effects that aren't necessary. Second foot gun is the missing cleanup. Let's take a look at an example. So here's a hook called window size, which on mount adds an event listener to the window, and then when the window size changes, it sets a new state. Here's the thing though, this happens every time the component mounts. So it mounts the first time, and as a listener, it mounts the second time as a listener. These listeners never get removed, and that is what is missing here. The use effect has in its syntax a way to describe a cleanup function that you have to call it to clean up event listeners and these sorts of things. Otherwise, you get a memory leak, and these memory leaks lead to, in this case, multiple settings of state, which again cause multiple re-renders. So do cleanups. Let's continue with our investigation. Next up, oh, finally, an actual detective. Hey, Benoit.
Ah, Commissioner, a most fascinating case you've presented here. A tangled web of decisions, if you will. Now, I've spent some time unraveling this mess and have come to an intriguing conclusion.
All right, Blank, let's hear it.
The app is guilty of two opposing sins. On one hand, it is downright negligent in its use of memoization, failing to use memo and use callback where they would have clearly reduced unnecessary renders. But on the other hand, where memoization is used, it's done so excessively and frivolously. Overuse of React memo on components that barely change.
Wait, so you're saying you're both overusing and underusing memoization?
Exactly. It's as if the developer couldn't decide whether to trust memoization or fear it. Instead, they've employed it haphazardly, sometimes ignoring it altogether, other times slathering it all over like butter on a biscuit.
And what's the impact of this behavior?
Chaos, Commissioner. Sheer chaos. Performance suffers where memoization was neglected, and the upwaste cycles where it's been over-applied. It's a textbook case of too much and too little, all at once.
Okay, Blank, thanks for the insights. Let's talk about memoization. So, if you recall, a component re-renders when its parents re-render, or when its parent re-renders. And remember this asterisks? Well, that's the thing. Sometimes you don't want a component to re-render when its parent re-renders. And for that, we have something called, a tool called useMemo. A component that doesn't render if its props don't change is called a pure component. And the way it works is that, let's say we have this my component, and under that we have an expensive component. Expensive in the sense not that it costs a lot of money, but it's computationally expensive. To memoize this, we do something like this. We call react.memo, and we receive a memoized component, which in theory works well. This component will not re-render unless input data changes. But this is the thing. Memoization is fragile, and by that I mean that it's really easy to break. Memoization has an overhead cost of CPU and memory, and when memoization breaks, you pay these costs of CPU and memory, but you don't get the benefit of just not having the component render too many times, or like when it's not necessary. Let's see an example of that. Let's say you have this memoized component, but then this memoized component receives children. This just now broke the memoization. Why? Because even though it looks like this component isn't receiving props, or that its props don't change, children are a prop. It's just that the JSX kind of hides it from you. And these P's, these new components, are again recreated by reference, are recreated and have new references every time app is re-rendered, which means that memoization got broken. So how do you deal with that? When dealing with these sorts of children, you can memoize the children themselves. And then pass along the memoized value again so that the reference doesn't change. Another paradigm that I see a lot is that sometimes you have your memoized component. It's never called memoized component. It's always called something like header version 2, whatever. And then another developer comes along. They don't know that the component is memoized. So they add prop, maybe they add style. And then again, we return to the previous issue of creating these new objects on the fly, which creates a new reference, a new object with a new reference every time the component is rendered, thus breaking memoization. And the question is there a magic solution for all this memoization stuff? And the answer is yes. It's called React Compiler, which is a relatively new thing that just came out into production out of beta about a month ago, and you can use it right now. There's even there was a talk about this just an hour ago. Highly recommend you go watch that, but this talk isn't about that. This talk is about stuff you can change in your codebase right now to improve performance, even before you migrate to using React Compiler. So, let's continue with the investigation. The next detective is from the FBI.
Something doesn't add up here. These aren't normal performance issues.
Okay, what do you think is causing them then?
Have you considered external interference? Forces beyond our understanding?
You mean like what?
There are beings who have been known to interfere with JavaScript runtime environments. They're trying to disrupt humanity's progress in web development to keep us from advancing too quickly.
And these beings, how exactly are they messing with React?
They're introducing unnecessary re-renders through an advanced psychic feedback loop. Think about it. Have you ever actually seen a virtual DOM? Or are we just taking React's word for it?
Wait, are you saying that the virtual DOM doesn't exist?
I'm saying we can't rule out the possibility that the app's performance issues are the result of external tampering by someone or something that didn't want this app to succeed.
Okay, Detective Mulder, I think we've heard enough.
You need to look beyond the DevTools profiler. There's a bigger picture here.
Yeah, I'll keep that in mind. So most likely, aliens aren't the cause of your performance issues, but you do have the tools to uncover what exactly is causing that. And this is my performance debug methodology. These are all the steps that it takes. First step is detecting what gets re-rendered. Then the second step is detecting why it gets re-rendered. And then that's pretty much it. I know you expected more steps, but that's all that we have. And I'm going to go over a few tools and methodologies, specifically React DevTools, React Scan, and the reading code. So React DevTools, you've probably heard of it. It's a Chrome extension you can install to kind of figure out what's going on with your React. Let's see this in practice. Let's say we have an app. We open up the extension. We turn on the settings, and in the settings, we turn on highlight updates when component renders, and then when you click on update name, you see that the name changes, but also a couple of other components re-render for some reason. Let's try to figure out why using React DevTools. So you open DevTools, and then you hit record, and then you click update name, and you click record again. And now you have a call graph of all the components that were rendered. So we go to the component that we want to investigate, this one, the name one, now the other one. And you see on the right that it says it got re-rendered because the parent component got rendered. That's weird. Let's look at the parent. And then it says the parent got re-rendered because the context changed. Interesting. So let's look at the code itself to see what went wrong. This is the component for the name that does use context, so it uses the context. And then this is the other component, which doesn't use context, but still got re-rendered for some reason. And now if we look at the context provider itself, we see the issue that I talked about earlier, where we have an object that is created again and again with a new reference, and thus affecting consumers of this context, even though we didn't mean to. Here's another tool called React Scan. And React Scan does a few things similarly and a few things differently. First, it can show you, like the first tool, what gets re-rendered as you change things, but it works a little differently. So, where did the demo go? Okay. Again, so we're on the same app. This time, though, we go to the code, and we add a script tag that calls React Scan from the CDN. So this is not an extension. This is something that actually runs on the page. And then you see on the bottom right, a new component added up that tells you the FPS, the frames per second. It also shows you what got re-rendered. And also, like React DevTools, lets you select stuff and tells you more information about them, like what got changed and why. It has optimization suggestions and all sorts of interesting things. And here you can see that the React context provider changed. We already knew that. It also tells you what values got changed, which is super handy. In HUD, we have this running on our development environment so that it's always open in the bottom, and if you see the frames per second start to drop on certain interactions or on certain pages, then you know something is going on with the performance as you're working on your code, which is nice. You don't have to open anything extra. So what if you can't figure out the cause though? Like sometimes your app is just a mess, and it's not one component that's at fault. You have several components. What do you do then? Well, if everything else fails, sudo rmf. And okay, I'm legally obliged to tell you that this is a joke. Don't actually run this on your computer. I mean, it will definitely solve most of the performance issues. It will cause some other issues, probably for your employment, but that's not what this talk is about. But what I do mean with deleting code is sometimes the old tried and true method of binary search is the thing that works. If you don't even know where to begin, and you know you have a performance issue somewhere in the app, then you go to the root JSX and you start commenting out and removing things until something like you see the FPS going up and you see the re-renders stopping. I know, like I'm not saying commit this code, right? But it does help to try to narrow down the problem if the scope you're working with is huge. Now, you might say, this sounds like a lot of manual work, to which I say, obviously, so let AI do it for you. And I managed to talk 25 minutes without mentioning AI, so that's quite a success, I would say. But if you just tell AI agent, solve the performance issues for me, it won't know what to do. Like it won't achieve any results. But luckily, we do have tools that help you do that exactly. The two that I'm talking about specifically for giving AI context is Chrome MCP, which lets an agent talk to the browser, see what's going on, read logs, get snapshots, change things, change the code, and get a positive feedback loop. And the second is giving the AI agent more context to know how to solve the performance issues. So Cursor has its rules and Claude has its skill, but essentially what it means is providing pre-baked context for the agent to start working with. Luckily, I already created this rule for you that you can start using right now. I'll give you a QR code in a few minutes, in a few seconds, for you to start working in your environments to give the AI opportunity to debug for you. Let me show you how it works. Let's say this is Cursor, and you give it a prompt. There's a React performance issue here. This is the URL. Help me debug it. It works. It loads the skill that we've just mentioned, and then it opens up the page in browser. You see that there's a performance issue. You see all the blue stuff re-rendering. Then it starts working through the stuff that we've talked about, commenting stuff out, searching for all the stuff that I mentioned, and it ends up actually finding the issue, solving it, and you see that the performance actually got back to normal. So you can kind of direct it at the problem and let it do its own thing, which is pretty cool. Thanks. So, in summary, be careful with use context. It's a really useful tool, but one wrong step, one wrong reference, and your entire app gets okay, I'm over-exaggerating, but a lot of stuff gets re-rendered that you didn't intend to. Use effects. Make sure that you actually need these and that you're using it for data synchronization and not just because. Memoize, but just don't put memoize on everything because that will be counterproductive. And lastly, you have visibility tools. If you feel that something is missing, that something is wrong, that you have a performance issue, you have a way to figure out exactly what is going on. Thank you so much. If you want to grab that skill, there's that QR here. And if you just want to talk to me or whatever, these are my credentials. Thank you so much.